Okay, we're continuing with our Econometrics final review with the last two questions. Question 27 asks about the difference between internal validity and external validity. We have mainly focused on internal validity throughout this Econometrics course, and it's achieved when inferences about causal effects in a statistical study are valid for the population being studied. So we're mainly concerned about causality. We're concerned that the coefficients are unbiased. And so we're concerned about relationships between variables. With external validity, we're more concerned about out-of-sample properties in terms of conclusions being generalized to an external population, not necessarily the population being studied. And so external validity is important for forecasting and predicting, but less important when it comes to causal inferences. So we again are focused a lot more on internal validity, and there are 5 main threats to internal validity that we've discussed. The first one is omitted variables bias. So if you are omitting an important variable from the regression, and that variable meets 2 criteria. So first, it's an important variable that is a strong predictor of the dependent variable. And secondly, it's an omitted variable that's strongly correlated with the independent variable or variables that are already included in the model. If it meets those 2 criteria, then the coefficients on the variables that are included in the model are going to be biased. Second one is incorrect functional form. With an incorrect functional form, you could be modeling something, for example, linearly. As we talked about in class, we might, if we're looking at hours of practice as the independent variable and a score as the dependent variable, you would want to model that quadratically, because that tends to increase at a decreasing rate. So you would want the correct functional form. If you have wages or salaries or income as your dependent variable, you would want to take the natural log in order to make it a more normally distributed dependent variable. So those are examples of changing the model so that it has a correct functional form. The third threat is measurement error. So with measurement error, the main concern with bias is measurement error in X. So do remember that measurement error in the independent variable is a lot more serious than measurement error in the dependent variable. In fact, measurement error in the independent variable will lead to biased coefficients, whereas measurement error in the dependent variable won't lead to biased coefficients. It'll simply lead to inflated or larger standard errors. So if you have larger standard errors, then your coefficients remain unbiased, but they're not as efficient as they should be or could be. The fourth threat to internal validity is sample selection. Now with sample selection, you may be especially concerned if people are volunteering to participate, say, in a clinical trial or in a survey, and so their characteristics may be different from those who are not included in the sample. And so your sample doesn't end up being completely random. And so one solution to this is conducting a randomized controlled experiment. Now the last threat to internal validity is simultaneous causality. And this will also bias your coefficients. And we had several examples of this. For example, in which if you have crime as the dependent variable, as a function. And we looked at this of police expenditures. You would expect if police expenditures were completely independent, that as they go up, crime would go down. But we don't necessarily see that, right? We often see that police expenditures might be higher in areas, where crime is higher. And so you might actually find yourself with a value for the slope that's opposite. That's the opposite of what you initially expected. Instead of being negative, it ends up being positive. Why? Because crime also has an effect on police expenditures. And so this will certainly bias your coefficients, and we would want to find a solution to that, and we did discuss several potential solutions to addressing simultaneous causality, and some are beyond the scope of this class.